What your stupid model predicts is that if you hold an object...
So this will be a lie. Obviously, my stupid model doesn't predict that at all. My model says if you're holding the weight, the pressure is going right into your feet, into the ground again. So you've just added a mass to your mass, and now your mass is adding more weight to the ground. But obviously, whatever your skeleton isn't supporting, you have to support by other means, and that means you're going to burn a lot of energy. The longer you hold that box, the more calories you're going to have to consume. Absolute fact.
And again, how many fucking times do we have to repeat this to you that, yes, of course, your body consumes more calories when holding a weight? Nobody denies that, Gary. Again, nobody denies that, Gary. Nobody denies that, Gary. Nobody denies that, Gary. Do you get it now? How many times do we have to repeat this? When burning calories because of holding a weight, that's your own metabolic energy being used, Gary. The energy is burned inside your body as heat. It's not stored in the weight that you're holding. The weight itself that you're holding is not gaining energy. You're not adding more mechanical work to the weight, and that's the fucking point. It's about the mechanical energy of the weight itself. If a force doesn't move something through distance, it doesn't do mechanical work on that thing. But spending more time feeling the force increases the cost for your muscles or machines, if the weight is held by a robot, for example. But it doesn't make the object itself gain more mechanical energy. Shit for brains.
Certain amount of distance from the ground, that object will gain energy over time. Even when you keep that object only 1 centimeter off the ground, if you keep it there for 1 million years, it will have accumulated so much energy.
So somehow he's saying the energy is stored in the object. Obviously, the gravity is not stored in the object. It goes right into the ground. So again, ludicrous. He's saying if I take this object and I put it on top of my head, okay, that somehow it's now collecting, 9.8 meters of extra force, and it's storing it. And so it's now in 2 seconds, it's got 19.6, and it keeps collecting and collecting more and more some kind of energy, when obviously the energy is going right through me into the ground. I've increased my weight. The pressure is going into the ground. It's not staying in the fucking object. So again, just a complete straw man argument. Complete nonsense argument.
All right, so hypothetically speaking, if an object wasn't supported by anything at all, so let's imagine an object floating in midair, not supported by anything such that the energy can't be transmitted through the supported materials, but gravity still acting on that object. Then according to you, does the object gain more and more energy over time? Does that mean that the object over time will start to heat up more and more, eventually turning into a molten piece of lava? Will the atoms inside that object become so extremely hot that it will turn into a bright shining source of light? Now I know this is an impossible experiment because an object always needs to be supported by something else in order to lift it from the ground. But this is just a thought experiment. I mean, your formula is energy equals mgt. So a mass being exposed to gravity gains more and more energy over time. So when a mass is floating in midair, not supported by anything, the mass itself will gain energy and will start to heat up, eventually turning into a bright star when left there for billions of years. But when the mass is supported by a table, for example, when a mass is resting on a table, now the energy that is collected by the mass is transferred through the table and into the earth. That's what you're saying, right? Now, if energy really grew just by time spent in a gravitational field, a rock floating in space near Earth, but magically held at the same height, would keep gaining energy forever. That extra energy would have to show up as heat or light, so after billions of years, the rock would indeed glow like a star. No one has ever observed anything like this. Rocks on tables, satellites in orbit, the moon itself, none of them slowly heat up just because gravity keeps pulling. So now, are you saying that an object resting on the surface of the Earth is slowly heating up the Earth over time? No ordinary heavy object sitting on Earth will heat the planet just by sitting there. For the Earth to warm noticeably because of a static load, that load would have to be astronomically large or cause long-term ground deformation, such as creep, sinking, tectonic adjustment, so that mechanical work is actually being done. And that work, not mere time in a gravity field, is what becomes heat. A rough order of magnitude estimate shows you'd need a mass on the order of 10 to the 20th power kilograms. That's hundreds of trillions of tons, acting with meter-scale subsidence per year to produce heat comparable to Earth's natural heat flow. That's enormous, much larger than any human-made object. Step by step, non-math intuition first. Static force does not equal continuous energy flow. If a book sits on a table for 1 million years, nothing moves, so no mechanical work is done. No continuous power is dumped into the table or earth just because the book presses down. Energy requires motion or a changing field. For the earth to heat up due to a load, the load must cause ongoing deformation. The ground creeping downward, rock flowing, frictional sliding, tidal flexing. That deformation is a displacement through a force, also known as work, and that work can convert to heat. Two ways a mass can heat Earth. During placement, if you drop a mountain-sized mass onto Earth, impact, the incoming kinetic energy is dissipated as heat immediately. That's transient but huge. Post-placement deformation. A huge static load causes the crust and mantle to slowly flow and settle, isostatic adjustment. That slow motion dissipates mechanical energy as heat while the Earth's interior rearranges. If nothing moves, nothing heats. After any transient adjustment finishes, the system reaches equilibrium and further heating stops unless some continuous motion, for example, tides, mantle convection, or continuing subsidence persists. Why Gary's "it all goes into the Earth" intuition is incomplete. It's true the support transmits force into the Earth, pressure, and that pressure is felt. But that is a static stress, not a power flow. Only if that stress causes movement, deformation, friction, viscous flow, is energy dissipated as heat inside the Earth. Static stress by itself causes strain, but once strain is established and stops changing, no further energy is dissipated. So saying all the energy goes into the Earth assumes energy is being generated continuously. But what is doing the generating? If nothing moves, nothing is generated. A heavy statue will not heat the floor over centuries. The table or ground will carry the load. No continuous heating is observed. What would heat the Earth in practice? Large mass impacts, asteroid strikes, immediate huge heating, continuous, large-scale geophysical motions, strong and persistent subsidence, very large tides, mantle convection, ongoing heating. But simply leaving a heavy object sitting still? No, unless it causes slow, continuous deformation that does work. And to have planet-scale heating, the mass and deformation rates must be astronomically large.